We need to take a look at compound shapes. Sometimes they're called composite shapes. It's the same thing. Other times they might even be called compound figures or composite figures. But basically, it's where you take a look at a shape and you see that this weird shape could be broken down into very familiar shapes. And if I wanted you to find the area of a composite shape, the first thing I'd recommend that you do is break it up into smaller pieces. So when I look at this shape right here, this pentagon, I see that I can make it into a triangle and also a parallelogram. So it's broken down into two different shapes in this case. And then if we can just get the area of each of those shapes, the smaller shapes, we can add them up later. So let's find the area of that parallelogram, shape 1 there. Basically, area equals base times the height, so that's 9 times 12. And now we can just go through and multiply that, and we get 108 yards squared. So let me just make a note right there in the figure. And if you've got like a composite shape in your figure and you're able to write the measurements inside of it, inside of the smaller shapes that you make, I would encourage you to do that. I would also encourage you on your own paper to like go ahead and use dashed lines or lightly draw a line in there that you can erase later if you need to, so that way you can actually see these divisions. Let's go through and let's do the triangle also. This one is our first instance of where we're having to kind of come up with some information. We know that the formula is 1/2 base times the height, so let's look at the base. Um, I see that this side of that parallelogram is 9 yards, so that means that the right side would have to be 9 yards also. So I could say the base of that um, triangle would be 9. So from here to here would be 9. So if we called this the base of the triangle, we'd be in good shape. Now, as far as the height, I see that from the bottom of the triangle to the top, you know, if we kind of turned our head sideways, this is 6 yards. So it would only make sense that from here to here would also be 6 yards. And so as a result, we could use that as our height. And now we could go through there and finish out the formula and find that that triangle has 27 square yards in it. And now after we do all that, add up your smaller areas. Find out that the whole shape is 135 yards, and don't forget to use the correct units, 135 square yards. Example 2 is very similar. You know, we see the shape. We try to break it down into smaller shapes. The first one, the green one there, is in a triangle form. So the base, we've got to work on it a little bit. Let's figure out what the base is. Well, there's the base. How long is it from the left side to the right side? Um, well, if you notice, this 8 inches is what's missing in the middle, so we could kind of put that up there and add those all the way across. 3 plus 8 plus 3 would be 14 inches. So the base of that triangle is 14 inches. So let's go ahead and put that into our formula. Again, anytime you see 1/2, you could just type it into your calculator as 0.5. But that base, 14 inches, that B right there would be 14. Now we just need to find the height of the triangle. Same thing we did last time. If from there to there is 12 inches, we could put that 12 inches right there in the center of the triangle at 90 degrees, and that would be our height. Go through, work out the formula, and we find that that triangle has an area of 84 squared inches. Parallelogram for the bottom, shape 2, that gray parallelogram, that would be an 8 by 8, and so we'd have 64 inches squared. Add up the smaller areas, we'd have 148 inches squared. Now, example 3, this one, I just wanted to show you a little bit. Technically, if you know that these two sides are parallel, it's a trapezoid, you know, and we can use this formula of the trapezoid. So there's the parallel sides. I could rotate my trapezoid around to make those my bases, and I just find the height and plug it into the formula. And I'd find out that it's 12 feet squared. That's trapezoid. We're talking about composite figures. Well, I just wanted to prove to you that even though this is a trapezoid, we could break this trapezoid down into smaller, familiar um, objects or shapes and be able to find the area of those smaller shapes, and we would still get 12 feet squared. So let's go back to the original one. Let's break it up into smaller pieces. I see I could slice off a top triangle like that, and we'd have a parallelogram on the bottom. And we've got these two shapes. So the triangle, There's our formula for it. There's a parallelogram. There's the formula for that on shape 2. And let's just go find our stuff. 1/2 would be written as 0.5. The base of the triangle, well, since the bottom is 4 feet here, I would know that this would have to be 4 feet as well. See how we're having to um, basically apply our understanding of parallelograms, or in this case rectangles. You know, this side would be the same size as this up here. So that would be 4 feet, and that's why we plugged 4 feet in for the base. The height of the triangle, we have to do something very similar. Since that right side of the parallelogram is 2 feet, the left side is 2 feet. Well, this whole left side of the entire shape is 4 feet, and if from here to here is half of it, that means that what's left over would have to equal 2 feet, because 2 plus 2 is 4. So the height of that triangle is 2, and we just go work out the area for that triangle. So we know that it's 4 yards squared. Parallelogram, that one's pretty simple. 4 times 2 is 8. So area of the parallelogram is 8, and 8 plus 4 is 12, just like we'd found out working out the trapezoid formula. So that formula, even though it's weird, it really does work. Last one. This is more of the idea of what I've been building towards. This is a little bit more complex composite shape. You take a look at it, you try to break it up into shapes here. I've got it broken up into about 4 different ones. And if we colored them to help us see it a little bit, excuse my messiness, we can see those 4 different shapes. And now we just go through and we find the shapes. So find the area of each smaller shape. Right there, I've got a parallelogram, so base times height. 7 times 2.5 is 17.5 feet squared. Now write that area right inside that smaller shape so I'll remember it. I come over to the triangle, 3 feet for the base, 2.5 feet for the height. I plug it into the proper formula, 1/2 times base times height, and I find out that I have 3.75 feet squared area inside that triangle. And I kind of took out that extra stuff just so I could write that in and let you see that. Now I've got to do the purplish pinkish shape and the light blue shape, and we're done almost. Let's do this one, 3 by 6, that's parallelogram. That would make it 18 feet squared. So I'll write this in here. And now, how do we find the height of this parallelogram for this purplish one? Well, I made a mistake. My bad. I know that the base is 2.5 because the top is 2.5. I know that, but I didn't put enough information in here. So what we need to do is we need to add in a piece of information. Let me add in this piece right here, and then let me put this piece of information back right here. From here to here is 6 feet. So I know from here to here is 6 feet also. So what we need to do is we need to say, hey, how about 6 feet minus this 2.5 feet to figure out what's here. So 6 minus 2.5 is 3.5 feet. So this height I needed on this purple one is 3.5 feet. Now to make sure that we're right, hey, what's 3.5 plus 2.5? It should add up from here to here. It should add up to be 6 feet because it's got to match the 6-foot side over here, and it does. Okay, they're both 6 feet tall. See, this is 6 and that's 6. So sorry I forgot that information, but now that we had that 2.5 feet piece of information in here, we know that this is 3.5 feet. The area is 2.5 times 3.5 to get us the area of 8.75 feet squared. Add up all of these areas, the 17.5, the 8.75, the 18, and the 3.75, and we find out that it's 48 feet squared. There's just kind of a fluke, we wound up with no decimals, but that's the main idea. Take these weird shapes, break them into familiar shapes that you know how to get the area. Have to reason your way through of how to get some of the information you need sometimes, but record your process, be very careful, and you should be able to get to the correct answer.